Good morning, guys. It's Miss Flurry here. So, we're going to study parent functions and transformations. So we studied piecewise functions and step functions and absolute value functions. So now what we're going to talk about is how those functions come to be. And everybody in just like anybody in a family, there are parent functions. So we're going to talk about our parent functions today. Okay, and so we have a family of graphs. That's what we're talking about. We have a parent graph, a parent function, a translation, reflection, a line of reflection, and a dilation. So we're going to talk about the parent function. So there are 4 parent functions that we need to talk about. The first one is a constant function. As you can see, it's y equals 1. Or y equals 0, y equals 3, y equals -4. It's just a constant function, which means that it's any real number, and it can be a fraction, it can be an integer, it can be a whole number. It's just a constant function, and it usually is a horizontal line. Okay. Then there's our standard identity function, y equals x, which is also a linear function. So the identity function is also linear. So this is a constant function. This is a linear function, as it says, linear function. F of x equals x passes through all points with a coordinate of AA, and it looks like a line. Y equals x is our parent function. So what we're going to talk about is, what are we doing to the parent functions to make a new graph? So again, these are parent functions. We need to be able to identify a parent function, and then we need to be able to identify what we did to the parent function to get the new graph. We talked about absolute value functions. Notice it's a V. Notice y equals the absolute value of x. That is the absolute value parent function. So we have y equals a number. We have y equals x. We have y equals the absolute value of x, which is an absolute value. And then we have our last one, which is called the quadratic function, which is y equals x squared. Please notice that in all of these functions, it's y equals a number, x, the absolute value of x, or x squared. Notice that there's no other numbers in the parent function. It is just y and an x. So before you graph, there's some questions that you need to ask yourselves, or before we graph and before we make our decisions, ask yourself these questions to help you identify the transformations. What type of function is it? What type of function is it? Is it a constant function, an identity function, which is our linear functions? Is it an absolute value function, or is it a quadratic function? So we have 4 functions. We have to decide what it's doing. Does the graph open up or down? And does the vertex lie on an axis? So those are the 3 questions you should ask yourself. So again, just to make sure, we have 4 functions. The constant function, where it's just y equals a number. We have our linear function, which is y equals x. That's our identity function. We have the parent function of y equals the absolute value of x. And then we finally have the last quadratic function, which is y equals x squared. So these are our parent functions, and now we're going to talk about the transformation that we do to the parent functions to get the other functions. Okay. So right here, so the transformation, if you have x plus h and h is greater than 0, that translates the graph h units left. If it's, notice, even though it's positive, it moves it to the left. If it's negative inside, it moves it to the right. If there is no h and it's just plus k, like the f of x function plus k, then it moves it up. F of x minus k is going to move it down. If you have a negative function, it's going to reflect it over the graph of over the x-axis. I apologize. If the negative number is inside, it's going to flip it over the y-axis. And then we're going to talk about dilations. Dilations move things, it either stretches them vertically, compresses horizontally, or stretches graph horizontally. So what I want to do is I want to talk about these when we go to graph, so you can actually see what I mean, because I'm pretty sure right now these are just looking like a whole bunch of words and you're like, what is that? So let's do the examples 1A, 1B, 1C, 1D first, and then we'll go and we'll talk about the transformations. So the first type of problem you're going to have tonight is you're going to identify the type of function represented by each graph. So what type of function? So notice it's not a parent function because we moved it down. See, it's moved down, but this is an absolute value function. So we're going to write absolute value. What is this one? Going left and right, that would be a constant function. U-shaped. U-shaped always are, do you guys remember? And from the front, you guys, you know, your notes are probably open. This is quadratic. And then our last one, you could put linear. I would be fine with linear, but probably identity, you would need to know that this is identity as well. Okay, so let's talk about what we've decided. So what we've talked about. We've talked about parent functions and we've identified our parent functions. We've also talked about transformations of functions a little bit, but we're gonna make that context when we go to do the graphs. Okay. So are we ready? We're good? Okay. So we're going to look at graph 2A. So it says describe the translation in each function. So a translation is going to move it up, down, left, or right. Since it's inside, okay, so let me show you. Since that number's inside, see how this number's inside? The translation graph H units left. So that means we're going to move 3 units left. So what that means, you guys, is we're moving the parent function 3 units to the left. So 1, 2, 3. The slope is 1, so we're going to go up 1 and over 1. And then we connect the dots. The points, not the dots, connect the points. So let me explain that to you again. So this is an absolute value equation. Because the 3 is inside the absolute value, I went to my handy dandy little chart, and it says that if the H is inside, it moves it to the left. So that's what I did. How many units? It's 3, so I moved it 3 units to the left. So when it asks you what type of translation, that's describing it, and then you graph it. Again, the 3 was in the inside. That's how I knew I needed to move it left. Okay, let's look at 28. I mean, not 28, 2b. Oh my goodness, you guys. Okay, so 2b, it says x squared minus 4. So let's look. Since the 4 is not inside a parenthesis or absolute value, it's more like f of x plus k. And again, because it says minus 4, so we're looking at f of x minus 4, where k is greater than 0. Don't worry, that's greater. So we're gonna translate the graph k units down. So it would be 4 units down. Because that is a negative 4, and because it's a negative 4, we're going down. We're going to count down. 1, 2, 3, 4. And you guys, you could make a chart, but it's kind of like what we've been doing. I mean, it's the parent function. So the parent function, it's just like a U. Okay. You guys, this probably isn't the best graph because it should have probably gone through the 2 because of the 4. And you can make a generalization of it right now. But the main thing is, and yes, I messed it up pretty bad, but the main thing is that you know it should go down 4 and that it's not gonna move in and out. Okay. We'll talk about that tomorrow when I see you. Well, for hybrid Bs. For hybrid As, I'll talk to you about it on Monday. Okay. Now, so we're looking at 3B. See how this is y equals the negative absolute value of x. So because there's a negative in front of it, okay? Now look at this. Negative in front of it, not inside of it, it's going to reflect the graph in the x-axis. So what that means is it's going to open down instead of up. And you guys, it's still going to be 0, 0, but it's just going to open down now. Okay, so this looks like the parent function, y equals the absolute value of x. The only difference, what we did to it, instead of it opening up, it opens down now, and that's because the negative's out front. Okay, so I just want to go back to this graph really quick, you guys. We moved it down, and we could have made a chart. It shouldn't have opened. Let me just show you what it should have looked like. Okay. It was x squared minus 4. So the first graph you see, guys, is going to be the x squared. The second one's going to be the x squared minus 4. So I'm going to hit graph. And it really helps if Miss Fleury has her stuff set up right. So I apologize. There we go. And it also helps if Miss Fleury just shuts everything off. Okay, now let's graph it. That's the parent function. And do you guys see? Look what it did. The parent function was the so that's the parent function, up and down. See, it just is at 0, 0. Then if I go to this one, there's the parent, and now it shades over. And see, it just shifted it down. So the reason my graph is not great is because I didn't draw it to go through x equals 2. Now let's look at 3b. The parent function would be a line, but because this is negative x and this is kind of like inside, what it's going to do is we're going to start at 0, 0, but instead of going up 1 to the right one, we're going to go up 1 and to the left one. And so it's just going to look like this. You guys, I always draw all my points. First of all, because my line's a lot straighter when I do that. And I get a better picture if I do all my lines. So we've talked about a translation, left or right. We talked about a translation, up or down. We talked about a reflection. So 3A and 3B are your reflections. So this would be a reflection across the x-axis. And this is a reflection across the y-axis. Okay, that's part 1.